In this lesson, you will learn to solve equations and inequalities involving absolute value. So let's start with equations first of all. Here we see the absolute value of x equals 2. Okay, so this might be a review from Algebra 1, but if not, I will go through what this means. So here we see this is the absolute value symbol, these vertical lines around the x. And what that means is that it's a distance. Okay, absolute value is a distance. And more specifically, it is the distance from 0. So the way that you would interpret this would be that the distance, or absolute value, of some number from 0 is going to be 2. So the question is, what number, or numbers, is 2 away from 0? Well, if we think through that on the number line, looking at 0, what number is 2 away from 0? Well, if we go to the right over 2 spaces, we see that 2 would be 2 away from 0. And then if we go the other direction, go to the left, -2 would be 2 away from 0. So the absolute value of x equals 2, x could be either 2 or a -2. And notice there is a positive and a negative component. There are 2 solutions for this. Okay, so let's move on to inequalities. Here we have the absolute value of x is greater than 2. Or another way of thinking of this is what number or set of numbers are more than 2 away from 0. So looking at the second number line, we're going to shade in every possible solution, everything that has a distance greater than 2. Well, what has a distance greater than 2? Well, anything past 2 over to the right, so 2.1, 3, 4, 5, etc., all the way over onto infinity to the right. And by the way, where does it start? Well, it's a greater than sign, meaning it cannot equal 2. So it can get very close to 2, but it's never going to actually reach 2. So we need to put an open circle around 2 to show that we're not shading in 2 because 2 is not an answer, but we can get very close to 2. Okay, now remember there is a negative component to this as well. So going the other direction, looking over here to the left, in the negative side, notice that we also have a whole nother set of solutions that are further away than 2. So what numbers are more than 2 away from 0 on the left side? Well, it could be -2 point something very close to -2. It can be -3, that's 3 away. -4 is 4 away. -5 is 5 away. And anything on to infinity to the left would all be further away from 0 than 2. Be more than 2 away from 0. And the question is, will it be an open or a closed circle here at -2? Well, once again, it's going to be an open circle because it can never actually reach -2. If it was at -2, it would be exactly 2 away from 0. But the way this is read says that x needs to be more than 2 away from 0, not equal to 2. So that'd be the graph for that one. And notice how we can also write this using algebra instead of graphing. We could write this as a compound inequality. We could write this as x is greater than 2 or x is less than -2. This would be the same graph as x is greater than 2 or x is less than -2. And then looking at the less than sign, the absolute value of x is less than 2. So looking at the number line, the question is, what values for x have a distance from 0 that is less than 2? So the distance from 0 needs to be less than 2. So you're looking at anything closer to 0 than 2. So it could be maybe like 1.9. It can be anything less than that. It could be all the way down to 1. It could be 0. 0 is 0 away from 2, or from 0, so that's going to be okay. We can keep going the other direction as well. Go in the negative direction. So -1 would be just 1 away from 0, so that would be fine. We can go all the way very close to -2. And once again, for here, this is a less than sign. It's not equal to 2 away. It's less than 2, so they're going to be open circles again. You're at -2 and +2. So what we've done is we've shaded in all of the possible solutions to this inequality. It is any value for x that is less than 2 away from 0. And now algebraically, we could also write this using a compound inequality. And this would be represented by the inequality x is less than 2 and x is greater than -2. So you can write this as a set of 2 statements instead of just the one statement. So now we've seen how to graph absolute values, but before we move on to solving with absolute values, please take note of these representations right here, here, and here. Okay, because this will be important as we get into the solving aspect. So notice for the first one, for the equal sign, when you have an absolute value equaling a number, you can get rid of the absolute value by making 2 cases. You can set the absolute value, or what's inside the absolute value, equal to a +2, and then equal it to a -2. Okay, that's going to be important as we move on. For the greater than sign, notice how we can represent this absolute value. So to get rid of the absolute value, what I can do is I can write the x by itself and then greater than 2. So I basically rewrite this initial statement except just take out the absolute value sign. But then your second scenario is going to be over here, and notice what happens. You're going to change the greater than sign to a less than sign, and the 2 becomes a -2. So for these, for the inequality ones, you're going to have your first case, which is pretty self-evident. Just take out the absolute value sign. But then don't forget about the second case, where you change the inequality from a greater than to a less than, and then change the sign from a +2 to a -2. Okay, also notice this connecting word, the or. So if it's a greater than sign, so greater than, it's going to be a or sign. So it sounds kind of like what it's going to be. So greater than, you see the looks kind of like an or. Greater than is going to be an or statement. And that's going to be important as we move on. Okay, so greater than would be an or statement. And then down here we have our third and final representation with a less than sign. So when you set up your 2 cases with a less than sign, it's very similar to the first one, where the only difference is the connecting word. So your first case, you just take out the absolute value sign. We have x is less than 2. So basically rewrite this, just take out the absolute value sign. And then your second case would be changing the sign from a less than to a greater than, and then changing the sign from a +2 to a -2. And then notice that the connecting word is going to be an and. So if it's less than, so less than will be an and then greater than will be an or statement. And once again, that's going to be important as we move on. And by the way, this is also true as far as your 2 cases are concerned. It's also true if it's got an equal sign with it. So greater than or equal to for each of these. Exactly the same thing, except for the graph would have a closed circle instead of an open circle. And then same thing with less than. If it's a less than or equal to, then all of these would be less than or greater than or equal to. And then the only difference would be the graph would be a closed circle instead of an open circle. Now that we have the graphing out of the way, and now that we have taken the time to show you how to set up the 2 cases, we're now going to work with solving some different equations. So we're going to begin with the equations with the equal sign. So we see here x plus 1, absolute value of x plus 1 equals 2. Now as we said in the last slide, if you have an absolute value sign equaling a number, we can set up two cases. We know that either this here, an absolute value sign, will equal a positive 2, or it's going to equal a negative 2. So we have two cases, and we can solve each of these using just normal algebra. So to solve this, the first equation, just subtract 1 from both sides. We're going to get x equals 1. And then on the other side, subtract 1 as well. So we're going to get x equals, and that's going to cancel, negative 2 minus 1 would give you negative 3. And that's going to be an OR statement as well. So here's another example. Here now we have more than just one thing on the inside. Instead of just x plus something, we now have a 2x plus something. So a little more advanced, but still the same concept, where I need to, because there's an absolute value sign, set up two cases in order to solve. Case number 1 is going to be this 2x plus 3 equaling a positive 7. Second case would be equal to a negative 7. So then just simply solve each equation to get your solution. So to solve, you just subtract 3 from both sides over here. You have 2x equals 7 minus 3 is 4. And then divide both sides by 2. You're going to get x equals 4 over 2, which is going to be 2. Same thing for the other equation. Subtract 3 from both sides. So you get 2x equals negative 7 minus 3, which is negative 10. And then divide both sides by 2. We're going to get x equals negative 10 over 2, which is negative 5. And then don't forget the OR in the middle. Here's another example. And this one's actually kind of a trick question, because notice that we have the absolute value equaling a negative number. Now before you try to solve this, just take a moment to think through what absolute value means. Absolute value, remember, means the distance from 0. So what you're stating here is the fact that this distance, the distance of this right here, is going to be negative 5 away from 0. Well, that doesn't make sense. You cannot have a negative distance away from 0. So therefore, this would have no solution. And the reason is simply there's never a negative distance. Now for each of these problems that we've done so far, notice that the absolute value has always been by itself on the left side. So all we've done so far has been just setting up your two cases and then solving the equations. Now if the absolute value is not by itself, the question is, well, what do you do? So there are three simple steps that you can follow to solve any absolute value. So we've already been doing two of those steps, where we've set up the two cases and then we've solved. But if it's not isolated, if it's not by itself, you need to do that first, isolate the absolute value, and then set up your two cases, and then you can solve. Okay, so as we go on to the next example, we'll walk you through those steps. In this example, notice that we have a 2 here out front. So this is not isolated. The absolute value is not by itself. Well, the way I'm isolating this is the same way that I would isolate a variable. So just for example, if I were to compare this to the equation 2x equals 2, where the only difference is instead of the absolute value, we just have an x. Well, we all know how to solve this one. We just divide by 2, right? So you have x equals 1. Same exact concept over here. To isolate the absolute value, we do the same thing that we did to isolate the x. So all we do is we simply divide both sides by 2. When I do that, I have the absolute value equaling 2 over 2, which is going to be 1. So step 1 is done. We have isolated. So step 1 is done. We've isolated. Step 2 is to set up your two cases. So we do the same thing we've been doing before, where to get rid of the absolute value sign, we make two cases where x plus 1 equals positive 1, or x plus 1 equals a negative 1. So this would be your step 2. So step 2 would be your two cases. And then from here, we can do step 3, which is solve. So to solve, step 3, we isolate the x. So we need to subtract 1 from both sides here. We get x equals 1 minus 1, which is going to be 0. And then same thing over here, subtract 1. We get x equals negative 1 minus a 1, not minus 2, minus 1 should give you a negative 2. So this would be your solution right there. Now it could get a little more tricky, where now we have multiple things going on. We have the 2 in front, like we did in the last one, but we also now have a negative 4 out here. So it's a little more involved, but still the same idea. And it's sometimes helpful to compare this to an equation we already know how to solve. So we know how to solve this equation, or we should, based off Algebra 1, where here, notice the resemblance. The only thing difference is instead of the absolute value, we put an x there instead. With this equation, we should know how to solve, where we add 4 to both sides. So we had 2x equals 2 plus 4, which is 6. So your first step over here in this equation was adding 4. Same exact concept over here. To isolate this absolute value, your first step will be to add 4 to both sides. When I do that, this will cancel, and I have 2 times the absolute value of x plus 1 equals 2 plus 4, which is going to be 6. And now it's the same thing that we had in the last example. Looking over here on the right side, we know what to do from here. If 2x equals 6, to isolate, we divide both sides by 2. We get x equals 3. Same exact concept over with the absolute values. To get the absolute value by itself, we need to get rid of the 2, and to do that, we simply divide both sides by 2. When I divide both sides by 2, I now have the absolute value of x plus 1 equals 6 over 2, which is going to be 3. So step 1 is complete. We have isolated the absolute value. Step 2 would be to set up your 2 cases. So we have x plus 1 equaling a positive 3 or equaling a negative 3. So step 2 would be your 2 cases. So we have our 2 cases, and then from here, all we do is we solve. So we subtract 1 from both sides here, subtract 1 from both sides for this equation. So we x equals 3 minus 1, which is 2. And then over here, we have x equals negative 3 minus 1, which is negative 4. So we have effectively solved this absolute value equation. Now we've used a lot of time in this video showing you how to solve equations. And this chapter obviously is on inequalities. So how does this relate to inequalities? Well, exactly the same steps are going to apply with inequalities. The only difference is going to be when we set up our 2 cases, and we're going to show that here in a second. So here's our first example. We have the absolute value of 3x plus 2 is greater than 4. Now it's already isolated. The absolute value is already by itself. So we can go directly into our 2 cases. And this is where it's a little different. And our 2 cases are going to be, in this case, 3x plus 2 is greater than 4. So the first case is identical. The second case is going to be changing this inequality from a greater than to a less than, and then from a positive 4 to a negative 4. So that's really the only difference, is we have to change the greater to a less than. So that's for our second case. First case is identical to the initial. The only difference is we're just taking out the absolute value sign. So take note of this pattern of our 2 cases and how to get from the 1 statement into the 2 statements. And then lastly, take note of this connecting word or. Is greater than, and remember if it's greater than or less than, greater than or equal to, it's going to be an or statement. So greater than is or, and then less than is going to be and. So because it's greater than, it's going to be an or statement. So we have our 2 cases, and then from here, we can solve both of these. So to solve this first one, we subtract 2. We get 3x is greater than 2. And then get x by itself, we divide both sides by 3. So we have x is greater than 2 over 3. And the second equation, same idea. Subtract 2 from both sides. We're going to get 3x is less than negative 4 minus 2, which is negative 6. And then divide both sides by 3, where we're going to get x is less than negative 6 over 3, which is going to be negative 2. And then don't forget the connecting word as well. This is an or statement. I'm going to show you one more with the greater than sign, because this one is kind of a weird one. And here we see 3r minus 12 is greater than 0. So first off, it's already isolated. The absolute value is by itself. And so all we need to do is set up our two cases and then solve. So your two cases, once again, would be simply taking the absolute value sign away. And we're going to get 3r minus 12 is greater than 0. And then your case number 2 would be 3r minus 12, and then change the sign from greater than to a less than, and then change this from a positive to a negative. But in this case, it's a 0, so it doesn't really matter. There's no such thing as a positive or negative 0. So we've set up our two cases, and now we can solve. So to solve this, we add 12 to both sides. We're going to get 3r is greater than 12, and then divide both sides by 3. We're going to get r is greater than 12 over 3, which is 4. And then case 2, same thing. We can add 12 to both sides. We get 3r is less than 12. Divide both sides by 3, and we get r is less than 12 over 3, which is 4. So the thing that is unusual about this one, I guess first off, is the 0. So positive 0, negative 0, same thing. But the other thing that's kind of unusual is at the end. Yes, this could be our final statement. R is greater than 4 or R is less than 4. But there's a better way of writing this. If we think through the fact that a number is bigger than 4 or less than 4, we know that the number can be anything except for the number 4. It's got to be bigger or less than, but it cannot never be equal to it. So r can be anything but 4. So the way that we can write this, that'd be quicker, would be r is not equal to 4. So this is the same thing as saying r is greater than 4 or r is less than 4. So just a little side note right there. This is a better way of writing right here. Now here's another example where now we have a less than sign, and then also we have some things happening out here in front. Okay, so this is going to be a little unusual as well, and I'll show you why in a second. But we want to isolate the absolute value first. It's not isolated yet in this case. So the 4 here, we want to get rid of the 4, and to do that, we need to subtract the 4. Because if we take 4, then subtract 4, we're going to be left with 0. Nothing's going to be left there. And subtract 4 over here as well. So what we have is a negative absolute value is less than, then 2 minus 4 gives you a negative 2. And now kind of the weird part is that we have the negative out here in front. So to get rid of the negative, we remember the fact that there's an unwritten 1 out here in the front. If there's nothing written, there's an assumed 1. Okay, so we have a negative 1 out here in the front. And if it's right next to something, let's say it was like a negative x is less than negative 2. Let's say it was like this. Then this negative 1 is being multiplied by that x. So to get rid of the negative 1 that's being multiplied, I can do the opposite of multiplying, which is going to be dividing by negative 1. So if I divide both sides by negative 1 over here, then I'm going to have x left over on the left side. On the right side, negative 2 over negative 1 gives you a positive 1. And then take note, though, when you divide by the negative, dividing by a negative will change this inequality from a less than to a greater than. And that's exactly what we have over here. We have a negative 1. So to get rid of the negative 1 that's being multiplied, we need to divide by negative 1. When I do that, the negative 1 divided by negative 1 becomes a positive 1, which cancels. And then negative 2 divided by negative 1 gives me that positive 2 over here. So when you divide by the -1, you get a +2. And once again, the less than becomes a greater than sign because I'm dividing by the negative. And so once again, what I have here is actually another greater than problem. So we've isolated. So that's good. And then step 2 is to set up our two cases. So your two cases are just like what we've done in the last two slides, where I can set 3k plus 1 to be greater than 2. And then case 2, I just switch the inequality from a greater than to a less than, and from +2 to a -2. So we've set up our two cases, and now we can solve. So when I solve for both equations, I'm going to subtract 1 from both sides. I'm going to have 3k is greater than 2 minus 1, which is 1, and then divide both sides by 3. So we have k is greater than 1 over 3. Then over here, on the other equation, same thing, or inequality, same thing. Subtract 1 from both sides. -2 minus 1 gives you -3, and then divide both sides by that 3 to get k by itself. We get k is less than -3 over 3, which is going to be -1. So this here would be your solution. Now up to this point, we've only dealt with the greater than sign. So the last two examples, I'm going to use the same examples that we used previously, except changing the sign from a greater than sign into a less than sign. So example 1, 3x plus 2 is less than 4. Same one we've already done before, the only difference is the less than sign. So solving, you already have isolated the absolute value, so we need to simply set up our two cases. So your two cases would be 3x plus 2 is less than 4. And then notice, because it's a less than sign, it's going to be an and connecting word. And then scenario 2 would be 3x plus 2. Change the less than to a greater than, and the +4 into a -4. And then everything else is going to be the same. Your solving will be the same. So we subtract 2 from both sides. We get 3x is less than 2. Divide both sides by 3. And we're going to get x is less than 2 over 3. And then over here, same thing, subtract 2. We get 3x is greater than -6. And then divide both sides by 3. And we're going to get x is greater than -2. And then don't forget the connecting word at the end. And then lastly, to finish this lesson, we are going to use the example where we have the 0 over here. So we need to set up our two cases. Case number 1 would be 3r minus 12 is less than 0. Case number 2 would be 3r minus 12 is greater than, and then change this from a positive into a negative. But in this case, they're both just 0, so it does not matter, positive versus negative. So your two cases would look like this. And then solving, you add 12 to both sides. We get 3r is less than 12, and then divide both sides by 3. We get r is less than 4. And same thing over here, add 12 to both sides. We get 3r is greater than 12, and then divide both sides by 3. We're going to get r is greater than 12 over 3, which is going to be 4. Now notice what we have here. We do have an and statement, but there's actually a better way of writing this, because it says here that some number, r, is both less than 4 and is greater than 4. Now if you think about that for a second, there is no possible way that we can have a number that's bigger than 4 and smaller than 4 at the same time. So therefore, the answer to this problem would actually be no solution. And this will conclude our lesson for today, and we will see you next time.